Alright, so welcome back to this channel. Okay, so in today's class video I'll be taking you guys friction and inclined plane. Okay, so today's class is divided into two categories. Very first category is friction, while the second category is inclined plane. Okay, so please stick to the end of this video because in this aspect there is usually a lot of calculation in this aspect, and usually in this aspect there are exam based questions that usually comes out from this aspect. Okay, so now let's start with the class video. Okay, now what is friction? What do you understand by the word friction? Okay, so what is friction? Friction is also an example of force. Yes, there are different types of force. We have tension, we have thrust, like there are so many forces. Okay, so friction is also a force. Okay, so friction is a force that do what? That oppose motion. Friction is a force that oppose motion. Now there are different types of friction. We have friction that act on solid. We also have frictions that act on fluid. When I talk about fluid are substances that usually move, right? Fluid are substances that usually move. Now examples of fluid are liquid and gas. Okay, so friction usually act on solid, friction usually act on liquid, as well as friction usually act on gas. Remember, liquid and gas, they are categorized as what? As fluid. Okay, now the friction that usually act on solid, they are known as what? They are known as solid friction. Okay, now under solid friction there are two types of solid friction. We have the static friction and what? And the dynamic friction. There's also another one which is also known as what? Rolling friction. Okay, but I'm not going to talk about that one. Okay, so there are two types of solid friction, which are static friction and what? And dynamic friction. Okay, now what is static friction? Static frictions act on what? This is a friction that act on what? On bodies that are at rest. I don't know if you understand. On bodies at what? At rest. Now let me go back again. Friction is a force that do what? That oppose motion. Okay, please take note that friction does not oppose force. Friction does not oppose force causing what? Causing the motion. I don't know if you understand. Okay, so friction does not oppose the force that causes the motion. What does friction do? Friction do what? Friction oppose the motion instead. I don't know if you understand. Okay, so friction is a force that oppose motion. There are two types of solid friction: static and dynamic. Okay, now what is static friction? Static frictions, this is a friction that acts on body at rest. When a body is not moving, that type of friction acting on that body is known as what? Is known as static friction. Okay, now let's take a good example. Let's take a good look at this diagram. Now if you look at this diagram, this is a body. This is a let's say this is a block, or let's say this is a body resting on what? This is a stationary body. Okay, remember, static friction usually acts on bodies that are at rest, right? Yes. Now, so this is a stationary body resting on what? Resting on a surface, right? Now, remember from our previous class, I told you guys that when an object is usually resting on a surface, let's say for example a table, let's say a block resting on a table or anything. Okay, so now there's usually an upward resistant force exerted by what? There's usually an upward resistant force exerted by what? By that surface. Yes, and that force is known as what? It's known as normal reactional force, right? Yes. At the same time, the body resting on the surface also exerts what? A downward force. Okay, and that downward force is known as what? Is known as what? Is known as weight. Okay, now if you look at this body is usually what? Usually at rest, right? Now the friction acting on this body, keep this body to be at rest, is known as what? Is known as static friction. Okay, the friction acting on this body when the body is at rest is known as what? Is known as static friction. Okay, now let's continue. Now let's say this stationary body. Now let's say you apply a force, a pull force. Okay, this is pull. This is pull. Remember, pull is a force, right? So now let's say you apply what? You apply a pull force on this object. You apply a force on this object, dragging the object towards this side. Now, where will the friction act? The friction usually acts what? In the opposite direction. Opposing what? Opposing the motion. I don't even understand. Okay, so let's say for example now this stationary body. Let's say for example this stationary body, you apply a force trying to pull the body to this side, trying to pull the body to this side. Friction, there will be a friction acting on what? Acting opposite to what? Opposite to this motion, trying to keep this body to be what? To be at rest. So that is what you see in this diagram here. You see, you find out that this is frictional force. This is the force trying to pull the body to this side, and this is the frictional force trying to oppose the motion in the opposite side. Okay, so that is to tell you that. So therefore, frictional force, the frictional force is equal and opposite to what? To the pull force. Okay, I don't even understand. Look at the friction is acting in this side, the pull force is acting in this side. Now, based on the fact that they are two are equal, this body will remain what? Okay, let me say, okay. Now, based on the fact that, remember, I told you guys that this body and this force is trying to pull the object towards this side, but there's what? There's a resistant force that is opposing the motion, preventing the body to drag to this direction. If you understand. So these two forces, they equal each other, making this body to be what? To be stationary, to be at what? To be at rest. Now, if you look at this place, you find out that frictional force is equal, but opposite to what? To the pull, but opposite to what? To the pull force. I don't know if you understand. Okay, so frictional force is equal. Please take note. In this scenario, static friction is equal, but opposite to what? To the pull force. If you look at it, frictional force is acting in this side, the pull force is acting in this side, so they are both acting what? In opposite direction. Okay, so this is why you find out that this is why you find the negative sign here. Negative sign shows that there are two are what? They are opposite to each other. These two forces are acting opposite to each other. Okay, but the two forces are what? They are equal. So that is why this object is stationary. Okay, now if this pull force is greater, than the frictional force, the body will slide, the body will start moving. Okay, so let's continue. As the force, which is P, the pull force, as the force, this arrow here means increase. I just did it to conserve space. Okay, so as the force, remember I told you guys the arrow means what? It means increase. Okay, increase. Okay, so as the force P, which means pull, increases, the frictional force do what? Also increases. The frictional force increases equally until a certain value, when static friction cannot increase further. Now let me break this down. Okay, now remember I told you guys that the body is kept stationary as a result of what? As a result of the frictional force and the pull force, they are equal. So based on the fact that they are equal, the body will not move. Yes, the body will not move. Now, but if we keep on increasing this force, if we keep on increasing this force, the frictional force will also increase. I don't even understand. Yes, trying to keep the body stationary. So I'm explaining this part now. If we keep on increasing the pull force, the frictional force will also keep on increasing. Now it will increase to a certain value. That value, now it will increase to a certain value. Now, okay, it will increase to a certain value and cannot increase further. I don't even understand. Now let's say we keep on increasing the pull force. Remember, increasing the pull force, we also increase the frictional force. So let's say we keep on increasing the pull force, the frictional force will increase until it gets to a certain value at which it cannot increase further. I don't know if you understand. Now that value is known as what? Is known as maximum static friction. This value is known as what? Is known as what? Maximum static friction. Now, when the static friction gets to that value, beyond that value, the static friction cannot increase beyond what? Beyond this value, which is known as what? Maximum static friction. I don't know if you understand. Okay. So let's continue. Now let's continue to, I will come back to this aspect, okay? Now let's continue to what? To dynamic friction. Now what is dynamic friction? Before I continue, static friction, you can also call static friction and limiting friction, okay? Yes. Whereas dynamic friction, you can also call dynamic friction sliding friction, okay? So let's continue. Now dynamic friction, remember there are two types, static and dynamic. Dynamic friction is a friction that hurts when bodies are in motion. Remember, static usually hurts when what? When a body is stationary, right? But in dynamic, when a body is usually in motion, when a body is moving, the frictional force that usually hurts on that body is known as what? Is known as dynamic friction, also called sliding friction. Okay? Yes. Now let's continue. When static friction reaches maximum value, remember I told you guys that, let's say when we keep on increasing the pull force, the frictional force will also increase equally to get if we keep on increasing pull force, the frictional force will also keep on increasing until it gets to a particular value at which it cannot increase further, and that value is known as what? Maximum static friction, right? Yes. Now when static friction reaches maximum value, which is what? Maximum static friction, the body begins to what? Begins to slide. Okay, so this is very important. Now then we ask you, at which condition will the body begin to slide? That is when static friction reaches what? The maximum value. Okay, beyond this value, this body will begin to what? Begin to slide. Now, and the friction acting on the body becomes what? Dynamic friction. Okay, now let me explain again. So let's say now when this body is usually stationary because of what? Because of this frictional force. Okay, now let's say for example, now let's say we apply a pull force, trying to pull the body towards this side. There's an equal opposite force resisting the motion. That equal opposite force is known as what? Is known as static friction. Okay, yes. But if we keep on increasing this force, the static friction will also increases equally with this what? With this force. When we keep on increasing the pull force, the frictional force will also increase until it get to a particular value where it cannot increase further. Okay, so when it gets to that value, this body will begin to what? Will begin to slide. Okay. Now, as the body starts sliding, the friction that now acts on the body is known as what? Is known as what? Dynamic what? Dynamic friction. Okay. So it's very easy. Okay. Now, another thing you need to know under friction is that the formula of friction is what? Is equals to what? Coefficient of friction and what? And the normal reactional force. Okay. Now the arrow cancel is also the same thing as what? It's also the same thing as N. Okay. And what is N? N is what? Normal reactional force. Okay. So the two, they are what? The same. In the place of arrow, I can also put what? I can also put N. Okay. So they are the same thing. Okay. So they are the same thing. Let me just put arrow here. Okay. So now this is the formula of frictional force. Okay. Frictional force is equals to what? Is equals to the coefficient. U is what? I'm coming. Okay, so let me clean this aspect. Okay. Okay, so U is what? U is the coefficient of what? U is what? Coefficient of what? Of friction. Okay. Yes. Frictional force is equals to what? Equals to coefficient of friction times what? Times the normal reactional force. Okay, which is also known as the N, which can also be was represented as what? Can also be represented by what? N. Okay, so let's continue now. What is coefficient of friction? You take notes. The important thing you need to take note here. Coefficient of friction, take note, is a dimensionless quantity. That means that it does not have dimension. Okay, so coefficient of friction has no what? Has no dimension. Okay. Now the reason is that the reason is because coefficient of friction is the ratio of what? Of two forces. Now let's say remember frictional force is equals to what? Coefficient of friction times what? Normal reactional force, right? Now if we make coefficient of friction stand alone, it will now be what? U equals to what? Frictional force divided by what? Normal reactional force. Now, based on the fact that both of them, they are forces, normal reactional force is a force. frictional force is a force. So both of them cancel each other. So this is why coefficient of friction, it has no dimension. Yes, it has no dimension. It has no SI unit. Okay, so U is what is known as coefficient of friction. It has no dimension. The reason why this quantity has no dimension is because it is the ratio of what? This is because it is the ratio of two forces, frictional force and what? And normal reactional force. Both of them cancel out each other. So this is why it has no dimension. Okay, yes. Now what is this coefficient of friction? What is this coefficient of friction? Now coefficient of friction tells us whether a surface is what? Is smooth or what? Or rough. I don't know if you understand. Okay, so coefficient, this U, which is known as coefficient of friction, it tells us whether a surface is smooth or what, or whether a surface is rough. Okay, now high coefficient of friction, it means that what? When coefficient of friction is high coefficient of friction, it means that that surface is what? Is rough. Now remember, when a surface is rough, that surface usually have what? Have high friction. I don't know if you understand. So the higher the coefficient of friction, the higher what the friction in that surface. Okay, so high coefficient of friction tells you that the surface is usually rough. Then low coefficient of friction tells you that the surface is usually smooth. Yes, meaning that surface does not have what? Does not have friction. I don't know if you understand. Okay, so this is all you need to know about friction. Okay, yes, static friction, dynamic friction. Okay, now one more thing you need to know. Okay, now the one more thing you need to know is that I'm coming. Okay, remember frictional force is equal to what? Coefficient of friction times what? Times normal reactional force, right? Yes. And remember, we have static friction. We also have what? Dynamic friction. Now this formula is for both of them. It's for both. Is let's okay. When you see this U, yes, and when you see F arrow equals to what? U subscript S arrow, then you see another one. F arrow is equals to what? U subscript and K arrow. Now this formula is for static friction. Okay, this S stand for static. Okay, why this K stand for what? Dynamic. Now dynamic friction, I told you guys, dynamic friction can also be called sliding friction. It can also be called what? Kinetic friction. Okay, so dynamic friction can also be called sliding friction or kinetic friction. So this K represents what? This K stands for kinetic. Okay, yes. So frictional force is equals to U arrow. Generally, frictional force is equals to what? U arrow. Okay. Now let's say we specify. I place subscript S under this U. It's telling us that this is the frictional force acting on what? On a body at rest. Now if I place subscript K, it tells us that oh, this is the frictional force acting on a body in motion. Okay. Yes. Now take note. Static friction is greater. Take note. Static friction is greater than dynamic. Okay, than dynamic friction. Okay, very important. Static friction is greater than what? Than dynamic friction. Okay, and also take note that the coefficient of friction acting in static friction is also greater than what? Than the coefficient of friction in dynamic or kinetic friction. Okay, so this is all you need to know about friction force. Okay, yes. Now let's move to the most interesting part of this class, which is inclined plane. All right, so let's continue with inclined plane. Okay, so this section is divided into three categories. Okay, so we will treat body at rest on inclined plane. We treat body sliding down an inclined plane, as well as we also treat body moving up an inclined plane. Okay, so now let's start with this aspect. Now, so these are an inclined plane looks like. Okay, so these are an inclined plane looks like. A plane, a plane inclined at an angle. Okay, so when an object is resting on an inclined plane, remember, resting in a surface, that's when an object rests on a surface, that surface usually exerts what? An upward force. That force is known as reactional force, right? Okay, so when an object rests on an inclined plane, when an object rests on an inclined plane, the plane usually what? Exact, I'm coming. The plane usually exact an upward force, okay? That upward force is known as what? Is known as what? Known as the normal reactional force, okay? Meanwhile, the object itself exerts what? A downward force, which is known as what? Which is known as the weight, okay? So resolving this resolving the weight into two components, we have what? We have another force. When we resolve the weight into two components, we have what? We have two other forces, which is known as which is known as uh, which is known as component of weight perpendicular to the plane. Okay, so this force is known as the weight component. This force is known as what? The weight component perpendicular what? To the plane. Okay, perpendicular to the plane. Okay, then there's still another force that is usually parallel to the plane, and this, okay, let me just use this part. Okay, so there's still another force parallel to what? Parallel, this is the plane. Okay, so this is the plane. There's still another force parallel to what? To the plane, and that force, please take notes, W sine theta always act in this direction. Okay, always act in this direction. Okay, so this force is usually perpendicular, is usually parallel to the plane, and this force is known as this force is known as the is known as the component of weight parallel to what? Parallel to the plane. Okay, so when we resolve the weight into two components, we have what? W cos theta and what? W sin theta. Now this W sin theta is known as what? Is known as the weight component parallel to the plane, while this W cos theta is known as what? Is known as the weight component perpendicular what? Perpendicular to the plane. Okay, so this one is known as the weight component parallel to what? This is the plane, so it is parallel to what? The plane. Okay, then this other one is known as what? The weight component perpendicular. This is the plane, so this is weight component perpendicular to the plane. So this is normal reactional force, this is the weight. This is the weight component that is perpendicular to the plane, while this is the weight component that is parallel to the plane. Okay, so W equals weight, N equals normal reactional force. W sin theta is known as what? The weight component parallel to the plane. W cos theta is known as the weight component perpendicular to the plane. Okay, now if you look at it in an inclined plane, take note, in an inclined plane, it is the weight component that is perpendicular to the plane that balances what? That balances the normal reactional force. Okay, so look at it here. If you look at it here, which force balance the normal reactional force? It is what? It is the weight component that is what? That is perpendicular to the plane. Okay, so N equals to what? N equals to W cos theta. Okay, so please take note. This part is very important. Okay, yes. While for the angle, I will explain that later. Okay, now let's move to this other aspect. Inclined plane. Okay, so there are three scenarios under an inclined plane. A body can be at rest in an inclined plane. Okay, body at rest in an inclined plane, body sliding down an inclined plane, and also body moving up an inclined plane. Okay, so let's start with body at rest on inclined plane. Okay, so remember W cos theta, it is the weight component that is perpendicular to the plane, and W sin theta it is weight components parallel to the plane. W is the weight, then N is the normal reactional force. Okay, well, I will talk about this later. Okay, so now when a body is at rest, on an inclined plane, when a body is at rest on an inclined plane, and that plane and that inclined plane is a rough inclined plane. Remember, and that inclined plane, the plane is usually rough, so friction usually hard. Okay, so remember, I told you guys that W sin theta always act in this direction. Okay, trying to bring the body to this side. Okay, so let's continue now. Body at rest. Remember, under static friction, I told you guys that static friction, this is a friction that act on what? That act on objects usually at what? At rest. Okay, so this object is usually at rest. Now the friction that usually acts in this object is known as is a static friction. Okay, yes, and static friction, based on the fact that W sin theta is trying to take is trying to bring the body towards this direction, the frictional force will oppose the motion. Now, there's a likelihood that the body will move to this. We move to this direction, right? Yes, there's a likelihood that the body will move to this direction. So the static friction will oppose the motion. The static friction is in the opposite direction, right? Okay, so let's continue. Remember, the normal reactional force is balanced by what? Is balanced by the weight component perpendicular to the plane, or you can say W cos theta, right? So the normal reactional force is equals to what? Is equals to W cos theta, right? Yes. The normal reactional force equals is balanced by this one, W cos theta. Now, how many force is acting on this object? How many force is acting on this object parallel to the plane? Now remember, you need to know the difference between parallel and perpendicular. For example, these two lines, they are parallel, while these ones, they are what? These ones, they are what? Perpendicular. I don't know if you understand. So parallel line, these are parallel, while these are what? While this is what? This is perpendicular, right? Yes. So let's continue. So in this scenario, these are the forces that are what? That are parallel to what? To the inclined plane. I don't know if you understand. So they are this is the inclined plane, right? So how many force is acting parallel to the plane? There are two forces, which is W sin theta and what? And friction. What about the forces that are acting? Now this is the plane now, right? And what about the forces that are acting perpendicular to the plane? Perpendicular to the plane. How many forces are acting perpendicular to the plane? There are two, which is the normal reactional force and what? W cos theta, right? So we know that normal reactional force equals W cos theta, right? So now how many forces acting parallel to the plane? There are two forces acting parallel to the plane. So the total force acting parallel to the plane is equals to what? Is equals to W sin theta. Now, are they moving in the same direction? No, since they are not moving in the same direction, we'll put minus, right? So minus what? Frictional force, right? So these are the total force acting parallel to the plane. While these ones, they are the forces acting perpendicular to what? To the plane. Now, since the object is at rest, since the object is at rest, A will be what? A will be 0. It's not moving, right? So the acceleration will be what? The acceleration will be 0. Now, total force. What is the formula for force? Force is equals to MA, right? So it will be what? MA equals to W sin theta minus what? Frictional force, right? Since acceleration is 0, 0 times M will give us 0, right? So we'll be left with 0 equals to what? W sin theta minus what? Frictional force, right? So if this frictional force comes to this side, turn to what? To turn to plus, right? So now be what? Frictional force is equals to what? W sin theta. Okay, so in the end of it all, let me clean this part. Call me. So in the end of it all, the normal reactional force equals what? Normal reactional force equals to W cos theta, right? Yes. Whereas the frictional force is equals to what? Is equals to W sin theta. Okay, you know why normal reactional force equals to W cos theta, right? Yes. Why you know why frictional force equals to W sin theta? Okay. So now let's continue. Okay, let's continue. Now, what is the formula for frictional force? I gave you guys previously. So you guys that frictional force is equals to what? The coefficient of friction times what? The normal reactional force. I told you guys that normal reactional force can also be represented by arrow or what? Or capital letter what? Or capital letter N. Okay? Or capital letter N. So I can you decide to use arrow or what? Or what? Or N, right? So since frictional force is equals to normal since frictional force is equals to coefficient of friction times the normal reactional force. Whenever we see FR, we'll put what? Coefficient of friction and what? And normal reactional force, right? So wherever we see FR here, we'll put what? UN is equals to what? W sine theta, right? Yes. Now, remember, N is equals to what? N is equals to W cos theta, right? N is what? Normal reactional force, right? So since N is equals to what? W cos theta. Whenever we see N here, we'll put what? W cos theta. So U times what? N is what? N is W cos theta. So it will now be what? W cos theta equals to what? W sine theta. So it's just easy, okay? So let's continue. Now, U W cos theta is equals to W sine theta, right? You know how we arrived in this to this aspect, okay? Now let's continue, okay? So let's continue. Now, making coefficient of friction to stand alone, we divide both sides by what? W cos theta. Dividing both sides by W cos theta, we arrive with what? We arrive with U equals to what? W sine theta divided by what? W cos what? Cos theta, right? We are not done yet. This W cancel this W, will be left with what? Sine theta divided by cos theta. Now, according to trigonometry in maths, sine theta over cos theta is equals to what? Tan theta, according to trigonometry, okay? So since we are left with sine theta over cos theta, sine theta over cos theta is the same thing as what? Tan theta. So that's to tell you that coefficient of friction is equals to what? Tan theta, okay? So that is just it. Now so that is just it, okay? So the important thing you need to take note of under this part, under body at rest on inclined plane, is that just know that N is equals to W sine and W cos theta. Then know that frictional force is equals to know that N is equals to W cos theta. Then know that frictional force is equals to W sine theta. Yeah, so that is just it, okay? From there, do your normal derivation. We arrive with what? Coefficient of friction is equals to tan theta. So this is very important, okay? Very, very important. Take notes. Coefficient of friction is equals to what? Is equals to tan theta. So there are certain questions. They will just give you the angle, and they will tell you to calculate for what? They will tell you to calculate for the coefficient of friction. It's just easy. Just put let's say put angle 30, for example. Coefficient of friction will now be what? Tan 30. You get your answer, okay? So coefficient of friction is equals to what? Tan 30, okay? Yes. Okay, so which other important thing you guys need to know about? Then the angle, the angle. Now this angle is known as what? It's known as angle of inclination. It's known as angle of inclination. Angle of inclination, okay? Now, angle of inclination. So this angle here is known as angle of inclination. Take note, this angle here is the same as the angle here. If this angle is 30, this one will be 30. If this one is 60, this one will also be 60. If it's 100, this one will be 100 as well. So if it's 90, this one will be 90. So just take note that the angle here is the same as the angle here. Okay. So this angle is known as what? It's known as angle of inclination. Now take note. This is very important. At the point of sliding down, remember from our previously when I was teaching you guys about friction. Now under static friction, I told you guys that when the pull force or when the push force increases, the static friction also increases. Now both of them will increase when we keep on increasing the pull force, the frictional force will also increase. Now to get to a particular value where the frictional force cannot increase above that value, applying more force, because at that value is known as maximum static friction. So that value is known as maximum static friction. So when you further increases the pull force, that body will start to slide, right? And during the process of sliding, the friction that's now acts on that body is known as dynamic friction, right? Yes. So now, at the point of sliding down, Remember, this object is usually at rest here. Yes, because of what? Because of this frictional force, and the rest forces keep it in this stationary position. Okay, the frictional force acting on this body is static friction, because why? The body is at rest. But when the body starts sliding down, the frictional force will not be what? Dynamic. Okay, so as the point of sliding down, this angle will not be called friction angle. Okay, will not be called, normally this angle is like this. I don't know if you understand. So at the point, if I'm not mistaken, at the point of sliding down, this angle will not be, is not called what? Now, this angle, which is known as this angle, which is known as angle of inclination, which is known as angle of inclination, as the point of sliding down, it's not called what? It's not called friction angle. It's not called friction angle. Okay, so it's very important. So this angle here is known as friction angle. Okay, yes, it's known as friction angle. Previously, it was called angle of inclination. So at the point where the object slide, at the point of sliding down, it is not called angle of friction, which is what? Which is theta. Okay, so that is just it. So these are the important things you need to take note. You need to take note of. You need to take note of the fact that n is equals to w cos theta, the frictional force is equals to what? W sin theta. Then the angle, this angle here is the same as angle here. Then yeah, I think these are the important things you need to know about, as well as coefficient of friction to be equals to what? Tan theta. Okay, so yes, take note of this. Very important. Take note of this. Take note of this. You can also take note of and some other things. Okay, so now let's move to the next part. Body sliding down an inclined plane. Okay, now for a body sliding down an inclined plane, now there are also two scenarios under this. Now one of the scenarios is that when the plane is frictionless, when the plane is smooth, and the other scenario is when the plane is rough. That is when the plane has friction. I don't know if you understand. When there is friction in the plane, I don't know if you understand. Okay, so like what I said two scenarios. Okay, for a body sliding down an inclined plane. Okay, so let's do the first scenario, and we'll do the second scenario as well. Okay, so now when the body now let's start with the very first scenario. Body sliding down okay, a smooth or a frictionless inclined plane. Okay, so now body sliding down a frictionless inclined plane. Now in this same scenario, when the body is sliding down, since they said a frictionless, so we'll remove what? We'll remove this one. Okay, now the difference between this and this is that when the body is at rest on inclined plane, the friction that was acting on that body was static friction, right? And apart from that one, the body was at what? Was at rest. That is, acceleration is zero, so it's not moving. Now under this other one, body sliding down an inclined plane. Now the friction. Now I told you guys there are two scenarios. One that has friction, one in which the inclined plane is frictionless, and the other one in which the plane has friction. Now, in the other one in which the plane has friction, the friction acting on that one is dynamic friction. Okay, because where the body is moving or is sliding. Okay, so and apart from that one, the difference between these two is that in this scenario, the body is actually sliding. It is moving, right? So therefore, it has an acceleration. And if you understand, this one, the body is at rest. There's no acceleration. This one, the body is not at rest. It's not at rest, and there's an acceleration. Okay. So now let's start with this first scenario. Body sliding down a frictionless inclined plane. Since it is a frictionless inclined plane, there's no friction acting. Okay, the body is just sliding down. So let's start now. Remember, how many force will not be acting parallel to the plane? Remember, this is the plane, right? This is the inclined plane. This is the plane. Okay. Yes. Now this is the body. Now This is the force acting parallel. Remember, these lines, they are parallel. These lines, they are parallel, right? So now, how many this is the force acting parallel to the plane, whereas these ones, they are the force acting what? Perpendicular to the plane. Okay, so perpendicular to the plane, we have the weight as well. Okay, blah blah. So let's continue. So how many in this scenario? How many force in a frictionless inclined plane now? How many forces acting parallel to the plane? So it's just only one, which is what? W sine theta, which is also known as the parallel component of weight, or yeah, parallel component of weight. Okay, so let's continue. So how many? Okay, the total force, how many force acting parallel to the plane is just one, right? Remember, this is a frictionless inclined plane, so friction is not acting. So the only force acting parallel to the plane is just W sine theta. So the total force acting parallel to the plane is just W sine theta. Okay, but we know that what about the total force acting perpendicular to the plane? Total force acting perpendicular. There are two forces acting perpendicular to the plane, which is N and what? W cos theta. Remember, N is equal to what? Equals to W cos theta, right? Yes. So let's continue now. Now, total force acting along the plane is equal to what? W sine theta, right? Now, the total force is formula for force. Force is what? MA, right? So what? MA is equal to what? W sine theta, right? Yes. Now, since the body is sliding down, the body is actually moving, right? Therefore, the body has an acceleration. So the body has an acceleration, right? Yes. Now, W here, W is weight, right? Now, where is weight? The weight is equal to what? Mg. So wherever we see weight, here we'll put what? Mg. So here will now be what? Mg sine theta, right? Yes. So this M will cancel this M. We'll be left with what? A. Acceleration is equal to G sine theta. Okay, so yes. So yes. Now worry about when, remember, we all know that normally we know that N is equal to W cos theta. We know that for sure. Okay. Now worry about when the body is sliding down a plane that has friction. Now when the plane has friction, when the plane has friction and the body is sliding down, remember, frictional force usually opposes motion. So if the body is sliding down in this direction, therefore the friction will act in what? In this direction. So the frictional force acting in this body that is sliding down, is it a static friction or dynamic? It is what? Dynamic, because where the body is moving or the body is sliding. Okay, so now in the other scenario, when the body is sliding down a plane that has friction. So this in that same scenario, we normally know that N is equal to W cos theta, so there's no problem about that one. Now, the total force acting along the plane, how many force will not be acting along the plane? It will not be two. W sine theta and what? And friction, right? So the total force acting in the plane will not be what? Will be W sine theta minus what? Minus friction, right? The reason why we put minus is because friction is going to this direct. The friction and this one's the opposite, so we use negative, we use minus, right? So yes. Now, formula for total force is what? Ma, right? So it's equal to W is what? Mg. Then we put the sine theta, then minus what? Minus frictional force, right? Yes. Now, but there's one thing. Remember, frictional force. What's the formula for frictional force? Frictional force. Remember, from previous slide, frictional force is equal to what? Coefficient of friction times the normal reactional force, right? I told you guys that arrow, we can use N as normal reactional force. We can use arrow as normal reactional force. We can use N, so they are the same thing. So I'm using N in this one, okay? So since frictional force is equals to UN, remember N is equals to what? W cos theta. So in the place of N, I'll put what? I'll put W cos theta, right? Yes. Now where is W? W is what? W is, we know that weight is always what? It's known that weight is always mg, right? Yes. Now between these two, which one is common? Between these two, what is common? What is common is mg. So ma is equals to what? We bring the two, what is common here is mg. So bring out mg, then bracket open, sine theta minus what? U cos theta, bracket close. It's the same thing. Mg multiplying sin theta, we have what? Mg sin theta. Mg multiplying u cos theta, we have what? U mg cos theta. So it's the same thing. So we arrive with something like this, right? Now what are we looking for? We're looking for what? The acceleration, right? So this m will cancel this m. We'll be left with what? A is equals to what? G bracket open sin theta minus u cos theta. So that is just it. So this is the acceleration. This is the acceleration when the body is sliding down a plane that has friction. While this one is the acceleration when the body is sliding down a plane that does not have friction. Okay, so that is just it. Now let's move to the last category: body moving up an inclined plane. So you can, okay, under the, I doubt if that we ask you question from all these parts. So I'm just doing this so that you can just have the knowledge. Okay, where there we ask you question, where they will ask you question is the application of this theory. Okay, is the application of this theory. So we come to that. We'll still go to that aspect. So, but right now, just know these things. Okay, and don't forget about u equals to we know that u equals to tan theta. Don't forget about that one. It's very important. Don't forget about this as well. So don't also forget about this one and w sin theta. You know how you can get it. So it's very easy. So let's continue. So let's move to the next aspect. A body moving up an inclined plane. Okay, a body moving up an inclined plane. Okay, remember we have done body at rest in an inclined plane, body sliding down an inclined plane. Then we are in the last category, which is body moving up an inclined plane. Okay, so now take note. I told you guys that W sin theta always act in this direction. Yes. Whereas friction force can act in this direction, can also act in this direction, depending on the direction of motion. Let's say, for example, now let's say the body is moving in this direction. Where will the friction act? The friction will act in the opposite direction, opposing the motion, right? Friction will act in this direction, right? Yes. Now, what about when the body is moving in this direction? When the body is moving in this direction, the friction will act in what? In this direction, right? So that is just it. Okay. So that is saying that friction can act on both sides depending on the direction of the motion. Whereas W sin theta always acts in this direction. Okay, always act in this direction. Okay, so for a body moving up an inclined plane, now this is moving up an inclined plane. Now this is the force moving the body. Okay, let me just use, instead of using F, let me just use P. Okay, so let's say this is the push force now, pushing the body up the inclined plane. Okay, so if this force, which is push, is pushing the body up the plane, the frictional force will act opposite to the direction of this motion of this body, right? So the body is moving like this, then the frictional force will act in opposite direction. Now, under this scenario where a force is moving is taking the body up the plane, under this scenario, how many force is acting along or how many force is acting parallel to the plane? There are three forces, right? Yes. What about perpendicular? These are the forces acting perpendicular to the plane, whereas these guys, they are the force acting parallel to the plane. Okay, yes. Now we all know that n is equals to what? N is equals to W cos theta, right? Yes. Okay, so now the number of force acting parallel to the plane, there are three forces acting parallel to the plane. So total force acting parallel to the plane will equals to what? If you look at it here, frictional force and W sin theta, they are acting in the same direction. Okay, while this one is acting in opposite direction, right? So total force will be equals to what? P, then minus bracket open W sin theta, then plus what? Frictional force, right? Yes. The reason why I put plus, yes, because both of them, they are moving in the same direction, right? Now this minus shows that these two forces, they are moving opposite to what? They are moving in opposite direction to this guy, right? So let's continue. Now, since the body is moving, it has an acceleration, right? So the total force acting is what? Is equals to what? Ma. So it has an acceleration, which is equals to the push force, then minus. Now W is what? Mg, right? Weight is mg, then sin theta. Now, what about friction? We all know that friction is what? Normal reaction, coefficient of friction are what? Arrow, right? Or coefficient of friction times what? Normal reactional force, right? Now, N is what? W cos theta. So, W cos theta. Now, what is W? W is what? Mg. So, to be what? W to be what? UMG cos theta, right? Bracket close, right? Yes. So, okay. So, why is common to these guys? This mg is common, so everything will be what? Ma is equals to p minus what? Mg bracket open sine theta, then plus u cos theta, right? Yes. So this m will cancel this m, will be left with what? A is equals to p minus g bracket open sine theta plus u cos theta bracket close. So this is just, so this is the acceleration acting on what? On the body. So in some particular question, they'll give you the force, they'll tell you to calculate for the and they'll tell you to calculate for the acceleration. Okay, yes. Now, like what I said earlier, I said they will hardly ask you questions regarding all these parts. Okay, now where they will ask you question is the applications of of all these guys. Okay, so now let's move to them. Let's move to the applications. Let's move to the applications of a body in an inclined plane. Okay, so I think there are about there are about two applications. Okay, there are about two applications. One where the body is connected uh, to another body that is suspended. You will see it. Okay, so let's continue to the next part, which is the application. Okay,